In this lesson, we're moving on to finding segment lengths, specifically segments formed by intersecting chords, secants, and tangents. So our essential question is, how do I find segment lengths? All right. Let's see here. It looks to me like I have two chords inside this circle, and we're going to find the measure of these two chords by multiplying the pieces of the chords together. The trick to this is staying on the same chord with your multiplication. So this is A times B equals C times D. So think part times part equals the part times the part. Next up, what if we have two secants that intersect outside of the circle? Now, that's a little different, okay? And as we look at it, we're interested in two different things here. We're interested in the outside part of the secant and the entire secant. Okay, the outside part of the secant and the entire secant. So in this case, it's the outside times the whole equals the outside times the whole. Outside times whole equals outside times whole. Our third possible situation occurs when you have a tangent and a secant. So with the secant, we're still interested in that outside and the whole. But with the tangent, that's the only part we've got to work with. So in this case, it's the tangent squared equals the outside times the whole. So tangent squared equals outside times the whole. All right, and now we get to actually try a couple of these. So let's see. I have two chords, and chords are part times part. So I'm going to do 6 times 6 equals 4 times 5x minus 1. Notice I put the 5x minus 1 in parentheses, and that's because I'm going to have to distribute. 36 equals 20x minus 4. So 40 equals 20x, x equals 2. Now I'm asked to find the length of BD. Let's substitute 2 in here. 5 times 2 minus 1 is 9, and BD is 4 plus 9, or 13. In our second problem, we have two secants. Secants, right, that is outside times the whole equals outside times the whole. So let's see here. Distribute. And this is 216. We're only asked to solve for x in this problem, so that one's not so bad. All right. The next one is a tangent and a secant. Remember, our rule is tangent squared equals outside times the whole. I want you to pause the video and try numbers 3 and 4 on your own, please. Alrighty, number 3, our tangent squared equaled the outside times the whole. Distribute and solve. Number 4, right? The outside times the whole, and the whole was the tricky part. 8 plus 3x plus 4 equals the outside times the whole. Again, the tricky part because there were multiple terms there. I simplified, I distributed, I solved. Let's take a look at number 5. All this distributive property and multiplying and stuff lends itself to some really nice problems. Let's see here. 2 chords, so this is part times part. X plus 6 times x minus 1 equals 12 times 10. Let's see. I have to FOIL this. X squared minus x plus 6x minus 6. X squared plus 5x. And I know I need this to equal 0. So minus 126 equals 0. I have a quadratic, right? Let's take a look at 126. 1 times 126. Let's see, 4 doesn't work. 5 doesn't work. 6 will work. 7 should work. 1, 56, 18. Let's see, 8 won't work. 9 will work. 10 doesn't work. 11 doesn't work. 12 doesn't work. 13 doesn't work. Okay, so I found all the factor pairs. Now I could have done this by putting y equals 126 divided by x into my calculator and then going to the table, but I was doing them in my head. All right, 126 is negative, so one of these factor pairs is negative. I look at the middle. The middle is positive, so the larger factor pair is positive. And the pair that will add up to a positive 5 is negative 9 and positive 14. So I split this. X minus 9 equals 0. X plus 14 equals 0. And I get x equals 9 or x equals negative 14. Now I need to stop and I need to actually put this back into the problem because negative solutions don't always work in geometry. We can't have a negative segment length. If I put negative 14 plus x, negative 14 plus 6, that's a negative 8. That's not going to work. So this is what we call an extraneous solution. And our only answer that works is x equals 9. This is why we've been having you factor for warm-ups lately, because you're going to have to factor. Let's take a look at the next 2 problems. Both 6 and 7 are going to require you to factor in order to solve. I want you to pause your video and give it a try, please. All right, as we look at this problem, I had to do the tangent squared equals the outside times the whole. Now remember, when you raise a binomial to the second power, you really have to write it down twice and then FOIL it. That goes back to a real common error in Algebra 1 that I want you to be careful about. Negative 299, I never would have found these factor pairs in my head. I definitely used my calculator using the y equals the number divided by x feature and then the table. Okay. And then I solved. I got my 2 answers because it is a quadratic. And then I checked the negative answer to see if it was possible in this problem, and it's not. The only answer is 13. Oops, let's see here. There we go. The next one was a little easier to do because the numbers were smaller. All right, we had two secants, so outside times whole equals outside times whole. And 24 is not bad to factor at all. But again, I had to try the negative solution and make sure that it worked in the problem. All right, so I want you to write what you should think about in the three different situations we talked about. Two chords, two secants, or a tangent in a secant. Write what you would think about in order to set up the problem as your summary.